Hello, we are going to do section 8.1. So in your textbook, we're going to go over basically kind of a revamped version of what problem 1 looks like. So there will be a couple problems where you guys will actually have to draw in the diagrams. But we're just going to be talking about right triangles basically. So it says, you know that the hypotenuse of a right triangle is the side that is opposite of the right triangle. In trigonometry, the legs of your right triangle are often referred to as the opposite and the adjacent leg. So you guys should know, like, opposite means across from and adjacent means next to. So we've seen that before with some of our geometry. So what we do talk about when we're talking about an angle, the angle that we always are going to refer to is going to be what's called our reference angle. So suppose I'm talking about angle A. Okay, the opposite side to angle A would be the one that's across from it. So directly on the other side of the triangle. You guys should know that the hypotenuse would be the part that's across from the right angle, which means the last side would be what we would call adjacent, and that would be the one that's going right next to angle A. So a couple things that we're going to do then are really just identifying the parts, and then we're going to talk about something called a ratio between all these different types of triangles. So for number 4 here, if you guys can skip around in your book, it says for triangles ABC and it should say DEF. Identify the opposite side, the adjacent side, and the hypotenuse, and we are going to use C as a reference angle. So notice I have two similar triangles here. Well, like I said, it looks similar. It looks like the angles are the same. We're going to use angle C, and then we're going to use angle F as our reference angles. So first of all, the one that would be the hypotenuse is always the easiest to label. Hypotenuse is across from the 90. So I'm going to do that in both of these. So your hypotenuse is AC, and over here your hypotenuse would be DF. And again, the side that is across from it is what we just call the opposite side. So this vocabulary really is important. It might seem like this stuff is kind of boring and dull, but it's really going to help with the trigonometry later. This is called your opposite side, and the one that's next to it directly, that's not the opposite, is what we call the adjacent side. So the adjacent side is also not, even though the hypotenuse and the adjacent are both next to this reference angle, the hypotenuse is the one that's across from that 90, which you guys can always identify right away. So now that we can identify at least what these terms are as far as the opposite, the adjacent, and the hypotenuse, we can move on and calculate some of these ratios. So the first thing here, notice that I'm only given 2 of my side lengths. These are my legs. So the first thing that I really want to do here is calculate what this hypotenuse is. Hopefully you guys are brainstorming right away. We can maybe use that thing called the Pythagorean theorem. So that's what we're going to do. I'm going to do 3 squared plus 4 squared equals this side here, which I'm just going to call x. So 3 squared is 9, 4 squared is 16, and that equals x squared. Together, this is going to total 25. So if x squared equals 25, when you take the square root of 25, x is going to come out to 5. Okay, so my hypotenuse is going to be 5. And C is going to be our reference angle, so the side that's across from it. So opposite is going to be 3, your hypotenuse is going to be the 5, and your adjacent side is going to be 4. So what we're going to do with these, it says determine the side lengths for each of these, the side length ratio. When we're talking about ratio, we're talking about dividing 2 things. So my side length ratio from opposite to hypotenuse, if you take the opposite of C, we're talking about 3. Your hypotenuse is the 5. It's across from the 90. So what I want you guys to do is get out a calculator and divide this out. And this is going to come out to 0.6. So the ratio of opposite to hypotenuse is 0.6. That's basically all we're solving for. For this next one, it wants to know adjacent to hypotenuse. So I want you guys to take the side. Again, we're talking about angle C. The adjacent side is the 4. And we're going to take adjacent over hypotenuse. Hypotenuse was 5. So you guys are going to do 4 divided by 5. Throw that in your calculator. And you will get 0.8. So your ratio from adjacent to hypotenuse is 0.8. And then the last one, we're going to do opposite over adjacent. So going back to this reference angle again, C is our reference angle. the opposite side to C is our 3, and the adjacent side is 4. So in your calculator, you guys are going to do 3 divided by 4, which is 0.75. So your ratio of opposite to adjacent is 0.75. It might seem like this stuff is really easy then, but it's only easy if you know the vocabulary. So if maybe there's a little confusion, go back like 2 minutes in this video and identify again what opposite and adjacent and hypotenuse mean, and calculating the ratios should be a breeze. So here's our two triangles. I'm just going to lay out that ABC is something we already had. We had 3, 4, and 5. Now, if I say DEF has 6, 8, and X, I want there to be an easy way to solve for X. So how am I going from 3 to 6 and from 4 to 8? Blah, 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 brainstorm, brainstorm, brainstorm. How would I go from 3 to 6 and 4 to 8? Hopefully you're thinking multiply by 2. So if you want to calculate X without even doing the Pythagorean theorem, if you know that this is 5, multiply 5 by 2 and X would be 10. So we have a 3, 4, 5 triangle, and over here is a 6, 8, 10 triangle. Which means, again, these two triangles were similar. I already have that the angles are congruent in all in both of these triangles. So what I want to do is analyze what the ratios would look like in this 6, 8, 10 triangle, and we're going to compare them to the ones in the 3, 4, 5. So here's our 6, 8, 10 triangle. So let's focus on angle F as our reference angle. And across from F, we're going to look at the opposite to the hypotenuse. Opposite would be the one across from it, so opposite is 6. Your hypotenuse in this case would be 10 because it's across from the 90-degree angle. So in your calculator, if you do 6 divided by 10, you're going to get 0.6. Let's take a look at what adjacent would look like. Adjacent over hypotenuse is taking 8 over 10 because adjacent is 8, and your 10 again is your hypotenuse across from the 90. So this is going to come out to 0.8. Now the last one then, if we do opposite to adjacent, I would be taking my opposite to angle F, which is 6, over your adjacent, which is 8. So in the calculator, if you put in 6 divided by 8, you're going to get 0.75. So what I want to do is kind of go back a slide or two. I have 0.6, 0.8, and 0.75. If I go back a couple slides, notice that this triangle was smaller, but since it's a similar triangle, your ratios are all the same. So again, if I go forward and look at this bigger triangle, the side lengths were larger, but the part that we're focused on right now is the ratio. And it looks like the ratios are the same because these two triangles are similar. So what you guys are going to do then is work through a worksheet. This was just a really short lesson just to get you guys familiar with the vocabulary. You're going to work through a worksheet that's going to have you do the Pythagorean theorem. You're going to identify similar triangles, and then you'll complete a bunch of these ratios.